So welcome everyone to this session on reinforcement learning. As I mentioned, in this particular session, we are going to talk about what the fundamentals of reinforcement learning. We will take couple of practical examples that how does it work in real time. We'll do some mathematics, right? That how does it work? How does the learning actually happen? And we'll take a scenario of Thompson sampling. I'm not going to teach you the technical jargons because there is lot, like you will study about beta sampling, beta graph, and different. I'm not going there in this session because it will get very complicated, as it's open for everyone. So so don't have this thing in mind that because I have not studied much, because I have not studied machine learning, I will not be able to cope it up. It is totally anyone who has with zero experience can also understand this. Okay, so I will try to make it that easy, but please feel free to ask questions during the sessions. Okay, so without wasting time, let's start the session. I'll share my screen. And so first of all, so we are going to cover below topics in the session. So the first one that we are going to the topics that we are going to discuss in this session, the number one is basically what is reinforcement learning, basically the definition of reinforcement learning, and basically we'll discuss couple of real-time examples where reinforcement learning comes handy, right? And after that, so we are going to study three scenarios. So we'll first discuss what is a multi-arm bandit problem. Okay, sounds very fancy, but it is not. Multi-arm bandit problem. This is what we are going to study. After this, we are going to study about. We will take one very simple example. How does it work? So basically, I will say, a very simple example of Thompson sampling. So as I mentioned, we are going to study about Thompson sampling in reinforcement learning. There are multiple methods of reinforcement learning. Thompson sampling. Okay, so that I'll show you very simple scenario. How does learning happen? Basically, so one example we'll study, and at the end, we are going to focus on the bigger example where we are actually going to study about what is exploration, what is exploitation. Does anyone know about it? What is exploration? What is exploitation? Okay, it's fine if you guys don't know. So what we're going to study, we're going to study a company has to, we're going to take a case study where a company has to launch an ad campaign. It has possibilities of five versions of an ad. How does it decide that how should it spend the budget on which particular ad to basically maximize its return, right? So it's going to be a case study on advertisement, right, where we will study about exploration and versus exploitation. Okay, this is the whole pillar of reinforcement learning. If you can understand this much, you are pretty good to go and study it in deep. Okay, so definition, multi-armed bandit problem, we will discuss Thompson sampling and case study we're going to study. Okay, so let's begin with the definition of reinforcement learning first of all. So let's try to understand. Let's discuss in more detail what is, and I would want everyone to participate in this discussion. This is not going to be a session where I'm just giving you some gyan and I'm going back, right? I want you guys to learn, interact, and just go back happy, right? Whatever time you're going to spend in the session. So reinforcement learning, as I mentioned, is a part of machine learning. It is machine learning has different scopes. Like you study about supervised learning, you study about unsupervised learning, you study about reinforcement learning there, right? So what is reinforcement learning? Now I would like to discuss in detail. So can please come and unmute, speak, or maybe put in chat box what they understand with reinforcement learning.
So reinforcement learning is where the model is learning on its own. So what we are doing is we are penalizing it for doing the wrong thing and we are rewarding it for doing the right thing. And in that process, it's learning on its own, and we are not training it on some data set like labeled or unlabeled data set.
Exactly. Anyone, any other definition?
Yeah, actually, from my perspective, that supervised and unsupervised learnings requires a lot of data set. So
Yeah.
instead of following on like how the data behaves, like taking out the features, it kindly tries to follow some kind of rules and try to see how is it gonna achieve a particular goal state. So
So
it
my
requires very less data.
my question comes here: why then, if supervised and unsupervised learning requires data, what is the problem with having data? If I can train a model with the data, what's the problem with that?
The real
So
times,
yes, go ahead.
Yeah, guys,
yeah,
you can go one by one, right? We'll take everyone's input. Yeah.
like because we might not get data for multiple problems that are discovered,
Exactly.
kind of.
You're saying right. You're saying it correct. Yeah.
Just adding to that point, uh, since he mentioned supervised and unsupervised learning, in
Yeah.
supervised learning we have a very simple objective that can be achieved even with hard coding. But for unsupervised learning, we need to teach a lot of things and scenarios that we can't even finish making. So for all those scenarios, we use unsupervised learning where the algorithm learns by itself, but for it to go specific direction or to complete or fulfill our needs, we reward it by following our line of thought and punish for choosing other line of thought to reach our goal or fulfill our project or mission.
Yeah.
Basically goal.
Exactly.
So that's why in unsupervised learning, these algorithms are a boon for us because we don't have to hard code every possible scenario for our goal.
Yeah, kind of. It's right basically, right? So first of all, the major classification is supervised and unsupervised. Supervised, you all know. Again, I'm not going much in detail there. That when you provide it a set of data and a label, right, and it learns based on the classification and the data that okay, for this a category should be this, and it based on that it learns. In unsupervised learning, you don't provide the label; it basically learns on the data. But in reinforcement learning, even that data is not there, right? So think of there are two ways of learning things in real life as well. Either I tell you that okay, let's say you're going to study Python, for example. I'll tell you that okay, this is the syllabus for Python, these are the topics, you should study this much this time, you should study this much this time, right? I told you basically a given your structure, and based on that you start learning. That is one method. Another method is you start working on Python. Right now you know zero Python. You start working as the problems come, right? Suppose right now you're working on a project which requires you to create an API. Tomorrow it requires maybe creating a classes and objects. Later on it requires you to do some pandas or something, right? So what do you do here? What is the difference in these two scenarios? In one scenario, I have given you a whole checklist and you basically try to follow that, right? And in the second scenario, you are free. You are like a free bird. You learn as things come and build your knowledge over the time. Yes or no? Or it's confusing?
Yes.
So can you tell me which one you think is better? Which one, like positive and negatives of both? Can you tell me, which one you think would be a better in general, or it depends upon the case scenario? What do you think?
Yeah, like I would like to say that in second scenario, you cannot might be deploying indirectly to the customer, because like suppose if you are learning on the fly, then you might be missing something. So it has to again iterate a lot.
Yeah.
Uh, it basically depends on the scenario. Just as you mentioned in first case, if it is simply typing, I can directly give you the paragraph or the things you need to type, and you can directly do that. In this scenario, it is fast and efficient, but it cannot handle all the scenarios that may happen or occur. But on the other hand, with the reinforcement learning case, or as the second case you mentioned about learning pandas and etc., it is very flexible and can handle many situations, but it is not fast or that efficient compared to the first scenario.
Exactly. So difference between those two is that if you go in the first method where I give you a syllabus and I tell you, okay, you learn all this, right? Okay, you will have a very good, you will have a proper roadmap. You might become a Python expert there, right? And then knowing that, okay, I know everything. Okay, that is the advantage of that. But the problem there is that you might not know, you'll depend on what I am saying. I might be the wrong person. I might give you a wrong roadmap. I might give you wrong topics, right? So you will learn based on what the data is, what the input is from my end. Agreed?
Yes.
Right? So in that scenario, you rely completely on the type of the data. The type of the data governs what your output is and how you are basically creating your model logic, right? That is the first scenario. In the second scenario, you are learning as the go. So you are directly learning based on the output, that, okay, output says this, and then you are tweaking yourself, right? So the advantage is that you are very flexible. But the disadvantage of that is that you might not know everything. Correct? Okay, you might know few things, but you might not know. So you are, I can say you are very sensitive to things. If some new data, if some new output comes, you might, if let's say if some new thing comes, right, you will try to learn that. If some other thing comes, you'll try to learn that, right? So basically you are a little bit, yes, you are flexible, but you will have a hard time in actually becoming a master, right? So a combination of these two is actually the best thing, where you put your supervised unsupervised learning as well, plus you add reinforcement learning. As an example of this is, for example, ChatGPT, right? In ChatGPT, you would have seen when you chat, at times it gives you option, right? Left, right. Yeah, I'm coming to that.
Better response.
Right. What happens? Let's say you're using ChatGPT, you see two options, that it gives you a left response, a right response, and you click on I prefer that response, right? Based on your selection, it will basically determine, okay, what type of output you want, and it will try tweaking it. Correct? So this is, again, we can go deep there, that how all this thing helps in AI, but first let's try to understand that how does this actually work, that how does my click, for example, in ChatGPT, I prefer response, make ChatGPT behave its direction towards me, or basically customize its answer towards me. That is what we are going to learn, right? And then we will go towards that, for example, how reinforcement learning will help in AI, or maybe any other thing. Okay, so is the definition clear to everyone? Reinforcement learning.
Yeah. Actually, can we say that second is much faster? Suppose if you want to have a project, right? So by the time you become a Python expert using first scenario, it will take a lot of time than the second.
Yeah, of course, it will take a lot of time. You will not have a clear roadmap, right? You will basically be responding to things. You will not be like, you will not have a concrete plan initially, correct? So now, yeah.
Excuse me. I just wanted to ask, is our reinforcement learning top to bottom approach or bottom to top approach?
As in, can you little bit explain?
As in, let's say supervised and unsupervised learning. In supervised learning, we are
Bottom to top, basically, because you are depending on the output, you are trying to control inputs. That's what you do.
okay. Okay.
Okay, so let's try to understand this example. You will have more understanding of reinforcement learning. Okay, so this is a scenario. This is a very, very famous, you can Google it as well, multi-armed bandit problem. Okay, so multi-armed bandit. Okay, it's a very famous uh, example in machine learning, right? So let's try to understand this from how does reinforcement learning relates to this. So first of all, multi-armed bandit, what do you mean by bandit?
Thief, Lutera.
Bandit is a thief or a lutera, right? Someone who steals your money. So this concept comes from it's a like long concept, I mean historical concept. Basically, earlier in US, like there were casinos, right? In casinos there were slot machines. Even now there are slot machines, right? So so these are basically why multi-armed, because they used to have these levers here. Okay, so that's why they are called armed bandit problem. So basically they are saying that these machines are nothing but thieves, Okay, why you think they are calling them thieves?
Because you always lose and not win.
Because you always lose. So basically, now think of a very simple example. Those who do not know how a slot machine works, very simple, that you basically put some number and you check some, right? If the number, it's just like any, for example, gambling thing works, right? You'll bet on something. If that number comes, if that particular combination comes, you win. Otherwise, you lose, right? And it was a very addictive thing in US. Even now it is. But so now thing is like that. Every machine, ideally, think like this. Let's discuss an ideal scenario. Ideally, each of the machine, can I say that should have a 50% probability of winning and 50% probability of losing? Yes or no?
Maybe.
Depends on
As
number of combinations.
Ideal scenario.
if there are only two combinations, yes.
There are only two combinations. Either you win or lose. Okay.
Yes, yes. Then it's 50-50.
50. It should be at least 50-50, right? That your chance of losing should be equal to chance of winning. Then only it makes a, for example, I would say a normal thing, right? Even if it is gambling, like you should have a 50% probability of winning, 50% of losing, right? So earlier, what used to happen? These all machines were 50% only. That 50% chances of winning and 50% of losing, and then people tried to find out patterns, and they actually cracked it. That okay, how can we win most of the times? Then what these companies did, actually, they tried to play with the logic of these bandits, these slot machines in the back end, and your probability of actual winning reduced. So, for example, if you come here, let's say this machine is there. Okay, in this particular machine, your probability of winning, for example, becomes only 40%. Okay, in this machine it becomes 20%. In this machine it becomes 35%. In this machine, let us say it's 15%, and let's say in this machine it is 50%, for example. Okay, but the problem is, in casino there are multiple machines, and let us say you have a fixed budget. Let's say you are going with a particular budget for, let's keep a budget of $1,000. You're going with a budget of $1,000. You want to maximize your return. Okay, you want that, okay, I should get maximum money. Ideally, you will play on which machine? Tell me. You will
50%.
D5.
play on D5, right? Because here you have a 50% of chances of winning there. So you'll put all your $1,000 on D5 because it has the probability of giving maximum return. But problem of the scenario is that you do not know these numbers in advance, right? If you knew,
Yes.
you would automatically go to the machine. The problem is you don't know whether you're going to win or not. So for you, if you look from the front end, all machines are equal to you, correct? So you cannot actually determine which machine is going to give you better result, or what combination should you, how should you split up your money so that you are going to get the maximum return. Is the problem statement clear to you guys?
Yes, yes. We need to find the machine or form a strategy to get the maximum return on our money.
Form a strategy so that you can maximize your return from this particular combination of machines, slot machines. Anyone, any doubt before I move ahead? So now again, if we go a little bit technical, right, you will, when you'll study Thompson sampling in detail, you'll study about these curves. These are basically beta distributions. One talks about confidence, one talks about reward, right? Those things. I'm not going into that technical right now. So because it will get confusing for people who are new to this. So right now, just understand this statement that we have a scenario that we want to maximize our return. And so tell me, think a little bit, what will you do? How will you spend these $1,000 on that you can maximize your return? What do you think could be a solution?
Weighted division.
Answers, try to give something. Okay, we'll discuss. Yeah, please go ahead.
Like we can give a weighted distribution so that
How will you give weighted? You don't know about any machine. Every machine is equal for you right now. The distribution that I showed, 50%, 25%, everything, that is there in the back end. That is what company has played with the devices in the back end. You don't know, right? That
So-
everything is same.
I would rather divide the money equally, or to be more efficient, let's say 200 of 1000 for testing and playing each of the machines, and after getting the results, equally weighting those results on those machine, and divide the rest of the $800.
So what you're saying, what will you do?
I will
You'll
first
take $100, you'll
use
take,
200 or $100 as testing point and
okay.
play each machine. So after getting the outcomes, I will use that outcomes to further distribute the next batch of money.
But how would you know $200 is the right amount?
Uh, I can distribute these. I can experiment the first amount of. I can adjust the batch sizes
You're going
basically.
right. You're going correctly. You're going correctly. Yeah. But
कि I can go $10 each, 1 cent each, like that.
okay. Okay. Yeah.
So
Actually, according to central limit theorem, so in statistics we have that. So I think there is an n. So there is a minimum n where I think we can observe that n. So you are asking now how much first sample will take. So I think from that, I think we can take a small sample, and because if we are getting a kind of distribution on a small sample, we can do distributed weight. Like we can weights or give weights accordingly.
Okay. Okay. No, but how will you distribute weights initially? That's what my question is.
Yeah. So according to central limit theorem, if n is greater than 30, I guess,
30 is what?
number of like
What
one
you're
time.
doing is sampling, right? That does not work here. That is a separate scenario. That what you're saying is statistical significance, right? That you
Yeah.
that does not work here. I mean that can, but that's not the right answer for this scenario. But yeah, I mean you're thinking it right, I would say. Okay. Okay. So it's fine, right? So basically, there are two things which you will study here. So three strategies can be there. Okay. One, strategy one will be that what I do, which is called an A/B testing. What will I do? I'll split this $1,000 into $200, right? 200, 200, 200. Okay. So I'm going to split the money equally on each of the slot machine. Okay. And I will basically try to expect some result. So now after this, I'll get to know which machine is better. Is this a right strategy or not? What do you think?
on the first try you can't. So basically most of the money will be wasted.
So basically, by the time you get to know the performance of each machine, you will spend all of the money that you have, right? $1,000. Yes or no?
Yes. Yes, sir.
Okay. Now, second scenario, which a lot of you guys mentioned, was that, okay, I will do one thing. I'll take $200 for testing and $800 for spend. Okay. What I'm going to do now, 200 I'm going to split equally here. Let's say 200 divided by $40 I will split. Okay. So I'll spend $40 on this, $40 on this, $40 on this, $40 on this, $40 on this. From the back end, we know that this is 50% return. This is, for example, 40%. This is 30%. Let's say this is 20%, and this is, let's say, 10%. Luckily, what happened out of all these 40, this one gave you better output. This out of 40, you got, for example, 20 in return. You got out of this 40, let's say, for example, 15. Out of this 40, you got 10. Out of this 40, you get maybe 18. Out of this, you got only 8, right? Because, so if you do the ratio, you will see that this is 50%. Okay. This is like how much? 30, approximately 35%, right? This is 25%. Okay. And this is 36, roughly around 45%. Okay, and this is your 8 by 40, so 16 plus 4, 20%, right? So now try to think this way. What happened here? Even though my machine, this one is worst, I got a better result there. And now what, so just based on initial experimentation, I saw that my machine 1 is performing best. So let's spend all the $800 on machine 1. But what will happen after that? Because overall its average is only 10%, I will end up losing the money. Yes, no, confusing.
It is correct.
Right. So the point is, how much money shall I spend on testing? How much money shall I not spend on testing? Or what is the right strategy? So there are two terms which you need to know in reinforcement learning. One is called exploration. Okay. One is called exploitation. Okay. Exploration means that you don't rely on one solution, you on one particular machine, you spend money equally, or basically you want to explore all the machines that you have. Okay, what is the drawback of this exploration?
Wasting might be.
Wasting, the A/B testing that we did, right? That what will you do? You
Yes.
end up spending money by the time you actually get to see some result. And one is exploitation. Exploitation means you don't basically spend money on all. What you do, you basically build some hypothesis initially and you spend on that only. Like this example here, I did some initial testing and I saw that okay, 50%, it's a good return. Let's spend all $800 on this. So I'm exploiting one resource only rather than exploring everything. Okay, now so my hypothesis is that to find the accurate solution, you need to have a perfect balance of exploration and exploitation. Yes or no?
Yes.
Yeah.
Right. So to have the perfect result, you need to have this a good combination of exploration and exploitation. And there comes what I'm going to teach you next, the concept of learning rate and all this, all those things. So I'm going to show you a very simple example of two. Let's discuss, maybe two shops are there, two food shops. We'll see how a person's experience at each of the shop basically changes his experience, right? Yeah. Did someone ask any question? Yeah, please.
Yes, yes. I just wanted to know what was the third strategy or the ideal strategy to win this.
One is exploration, second is exploitation, third is a combination of both.
Okay. Thank you.
Okay. So so let's come to this, what we discussed. So we have just covered definition. We covered what is a multi-armed bandit problem. This is a problem that we are going to solve. And this is not just one multi-armed bandit. Think what we are going to study. We are going to do a case study of advertisements. A company wants to launch 5 advertisements. Each advertisement will have certain click-through ratio, right? We want to see how should that company spend its money so that it can basically maximize its results. Now first let's study a little bit now on Thompson sampling. Okay. And anyone, any question so far? So what I'm going to do, I'm going to create a scenario that there is a guy, he wants to explore 2 restaurants. Okay. Let's call Pizza Hut and Domino's. Okay. So what I'm going to do, let's say this is a pizza place. Okay. Let's call it Domino's. Okay. And you have another place called as Pizza Hut. You want to try the pizza of both the places, and let's say there is a, for example, there is this person, he wants to eat pizza. Okay. So let's call his name, for example. Let's give him any name, Sam. Okay. So Sam wants to eat pizza, basically. Sorry. Yeah, Sam, this guy wants to eat pizza, and he has two options: Pizza Hut and Domino's. Okay, he wants to. Now, point is that, tell me, initially before he starts eating, right? He has no bias for Domino's. He has no bias for pizza. But what he wants, that over the time he should go only to the restaurant which which basically tastes better, which serves him better. Okay. So can I say that initially the probability of going Sam to each of them is 50-50%? Can I say that?
Yes.
Because he has no bias initially. So the probability of selecting each of the, this is exactly what the multi-arm bandit that we were doing, just that here we have only two options. Okay. So the probability of this Sam going to Domino's or a Pizza Hut is 50-50%. So what I'm going to do, I'm going to draw up a line, for example. Let's simply draw a line. Okay. Which will show you the probability of going each places. So if I say this is 0%, okay, let's say here it's 0%. At center it's 50%, okay, 50%, and at right it's 100%. Wait a second, let me do this. Okay, so let's say this line represents 0 to 50% represent Domino's, and then I have this 50% for this particular thing. Okay, Pizza Hut. Okay, so let's change the color to probably green here. Okay, so let's say this is a distribution that 0 to 50% is here and 50% here. So equal probability of both the things. Okay. Now, initially, suppose Sam has to decide which place to go, Domino's or Pizza Hut. So right now, because he has zero bias, can I say that he has equal probability of going to either Domino's or Pizza Hut?
Yes.
So what he does, so how will he decide at which place to go?
He can.
Let's roll a die. Okay, what we'll do, let's assume this is a single line. Okay, he will roll a dice basically. At whichever mark, if it lies on the green, he'll go to Pizza Hut. If it lies on the red, he will go to Domino's. Now, because the probability is equal, so there is equal chance of him going to the each of the places. Correct?
Yes.
Okay, so let us say he rolls the die for the first time and he gets the dice come between 0 to 50. Okay, so he will go to Domino's. Okay, he goes to the Domino's, he eats the pizza, and let us say he, for example, let's say he liked it. Okay, so he gets an option to reward the restaurant, right? We speak about giving a reward. So when it comes to, so let's say he can either give a reward of either 0 or 1. So you can either reward 0 or 1. Okay. So the point is that, let's say he comes to Domino, he liked it. So what reward will he give here?
1.
He'll give a reward of 1. Okay. he liked it, and yeah, he liked coming here. He had a good experience. Now tell me, based on this, if next time onwards he says, okay, I like the Domino's, so I will only go to Domino's. Is that a right strategy?
No,
No.
Why?
he hasn't explored all the options.
First, he has not explored all the options. He has not explored Pizza Hut. Second, he has not. What if Domino's was good this time? Next time it might not be good, right? So neither he has explored all the options, neither he has exploited things properly. Yes, no, confusing.
Yes.
Okay.
Yes, sir.
But can I say that his inclination towards Domino's will increase next time? Does not matter.
Definitely.
Definitely, because I'm not. He had no experience here, but he had a good experience at Domino's. So his inclination towards Domino's will increase. So can I say that the next time his probability of coming to Domino's will be slightly more than coming to the Pizza Hut?
Yes.
Okay. Now here comes, how do we calculate that probability? Okay. This is where I was talking about how does that reward thing actually work. So there comes a very simple formula. Okay. It's a very basic formula, not a confusing formula. You'll say new probability, okay, is equal to old probability plus learning rate. I will speak about what is learning rate, okay, multiplied by reward minus old probability. Okay. So what I will do, let me just stretch the formula. Okay. So this is the formula. What it says, new probability is equal to old probability, that is 50% plus learning rate multiplied by reward minus old probability. Okay, let's try to understand this a little bit. When he went here, so if I talk about new probability, what was his old probability?
50%.
0.5, okay? Plus, I have not spoken about learning rate yet. I'll speak about it. Now, did he give a 1 or a 0 here?
1.
1. What was his old probability?
50%.
50%.
Can I say it become 0.5?
Yeah.
Okay. So his new probability of going to this particular place, Domino's, is 0.5 plus learning rate into 0.5. Now, don't worry if you don't know what is learning rate. Now, this is a very simple maths. Learning rate, let me tell you, it varies between 0 to 1. Okay. Now, tell me this, what will be the impact of learning rate on this new probability? Shall learning rate be high? What should be a good learning rate value? Even if you don't know anything, you can still answer this. So try to think, if you keep learning rate, if you vary the value of learning rate, how will it affect the new probability?
If learning rate have increased, then the probability also increases.
It should be between 0 and 1 because it's a
It is between 0 and 1. That I'm telling you. But should it be towards 0? Should it be at 50%? Should it be towards 1? What do you think?
It should be towards 0 because we have to slightly increase it.
So assume, let us say I keep the learning rate 1. What will happen if the learning rate is 1?
He will keep going to Domino's and never try Pizza Hut.
It will become 0.5, so probability will become 1. So the probability of Pizza Hut will become 0, probability of Domino's will become 1. So in just one test, with just one test, what will happen?
He is biased.
So which one test?
Domino's.
Okay, I should only go to Domino's. Correct? Yes, no, guys. Tell me if it is confusing.
Yes, sir.
Okay. What if he keeps the learning rate 0? What will happen if I keep the learning rate 0?
He will keep going to Pizza Hut and never try Domino.
No, think again.
No, he is
There
between.
might be a
No,
chance of
he will
going
try
both
Pizza
ways.
Hut.
He'll try
His
Pizza Hut and
probability will be
Domino's.
same. The distribution will not. His experience at any place will not affect his probability. Because see what will happen, this term will become 0, right? If learning rate is 0, this will become 0. Am I right? If old probability is equal to new probability, right? If think like this, here if I make learning rate 0, what does it mean?
His experience is not impaired.
Old probability equal to new
New probability equal to old probability means his experience at any restaurant is not helping him to make the next decision, right?
Yes.
The learning rate should be equal to 0, but
Can I say that learning rate
0.
should not be 1, learning rate should not be 0? Can I say this
It should
much?
be, yeah,
Yes.
it should be in 0.0.
The higher
very,
the
very
learning rate, more sensitive you become to your every experience. Can I say this?
Yes.
So it's very simple in real life, just based on certain examples or certain, for example, I'll take a very simple example. Let's say someone does not know Virat Kohli. Okay, he opens TV, sees Virat Kohli gets out. He'll say, oh, he's a bad player, right? He just gets out every time, right? This is what, like, just based on one experience, you're deciding something, right?
He needs to watch more times.
He needs to watch him more time. He should have watched him over the years. Second scenario, a guy is there who is very much biased towards Kohli, and throughout years he's saying that no, he's best, right? He does not encounter his current form, that how is Virat Kohli playing right now, correct? So their learning rate becomes 0, and in one scenario learning rate becomes 1. In one scenario you become very much like sensitive to every experience that you have. In one scenario you do not give a damn that whatever experience you are having, you stick to the whatever bias you have initially, correct?
Correct.
So this learning rate should be a number which should be experimented over time. It depends upon the type of case that you are doing. Generally, experience says it should be around 0.1 to 0.15, but it is not a fixed number. This is something you learn over the time. You train your model, right? And you see what type of output is coming, and that's how determined. But my experience says a learning rate of 0.1 is very good to start with. Okay, so what will I do? A new probability will become 0.1 into 0.5, correct? So what will it become now?
0.65.
You need to learn some maths.
0.5.
It's 0.55.
0.55, yeah.
I'm kidding. I'm just don't mind. So it's 0.5 plus 0.05, right? So it's 0.55. So what will happen? This red will become little bit. Can I say that red will become little bit? Like length will increase. So this will become 55%. Correct? Yes or no, guys?
Yeah.
So the new probability of going to Domino's becomes 55%, and here it becomes 45%. Right? Now, next time. So now, let's say he rolls the dice again. What is the probability of die coming towards Domino? Now it's higher towards Domino's, but it can also come towards Pizza Hut, right? I'm not saying that it will only come toward Domino, because probability is still almost similar, only 55-45, only 5%, 10% difference is there, right? So let's say he rolls the die again, and it again comes to Domino's. Let's say it again comes here. Okay, so what will new probability become? It will be 0.55 plus 0.1 multiplied by 1 minus
0.5.
0.55, right?
Shouldn't that be 2, because he will again reward 1?
No, but I'm only talking about this particular instance, right?
Okay, okay.
2 is already in, because he had a 1. Now we have shifted, included that 1 in 55%, right? How did this
Yes.
55% come? This 55% came because there was a 1 here. He had a good experience. So we have incorporated that here. Is it clear?
Yes.
Anyone, any doubt in this? Please tell me. So what will this become? 0.55 plus
0.045.
point.
0.45.
0.45.
So what does it become?
0.595.
So 0.5.
5.
Can I say it's 0.6?
Yeah.
Okay, roughly it's 0.6. So I'll say it becomes 60%. Okay, so this becomes 60%. This becomes 40%. Okay, and sorry. So this green line will further reduce, right? And let's say this increase, the red line towards it, and this becomes 60%. Now what he does, he rolls the dice again, and now it comes to the green. Now he goes to the Pizza Hut, and at Pizza Hut he gets a bad experience. For example, let's say the pizza was not good or service was not good. He gave a thumbs down. It's very similar to what you do when you in ChatGPT. I prefer this response or that response, right? You give 1 to 1 and you give 0 to other, right? This is something like that only what is happening here. So what is the probability of Pizza Hut now? New probability of Pizza Hut. Let's try to calculate that. It will be equal to 40, basically 0.4 plus 0.1 into reward. What is reward? 0?
0.
Minus 0.4.
0.4.
So it becomes 0.6 into 0.06. 0.06. Is it plus or minus?
Negative.
Minus 0.06. So what will this become? Tell me the number.
0.34.
0.34.
0.34, right? So what does this become? Instead of 40, it will become
34%.
34%. And if it is 34, this will automatically become
76%.
66%.
Okay.
Okay. So what will happen? This green line will further reduce, and this red will increase. So this becomes 66%. Okay. Now let's say after a lot of experimentation, lot of spending time, because what will happen now? Suppose sometimes you will have a bad experience at Domino's as well. Then red will decrease. Sometimes green will increase. A combination of that will keep on happening. And after a certain time, you will see this number fix. It is neither increasing nor decreasing, and that will become your true. Basically, I would say your true value, right? And so here, what you have done, you have explored as well, and what you have done, exploited as well, right? This is whatever I showed you. This is how reinforcement learning works, or this is also called the Thompson sampling. That you basically now what all these are called, these terms, like for example, we had 2 options, right? These are called environments in the technical jargon of this particular thing. This particular person who is exploring all this particular person is called agent in this scenario. And there are some other jargons as well, you don't need to know right now, right? But tell me, do you guys understand how the experience of this particular guy at different places is helping him learn eventually and deciding what restaurant he shall visit? This is how your reinforcement learning works. Is it clear or confusing? Yeah, please.
Exploitation will be done after, right? We hadn't done exploitation here till now. After probability switch, then
Once you have reached a certain number of level that it is not increased, right? Then you do exploitation, right? But point is that you're parallelly doing exploitation as well. At one thing you're going again and again as well. What will happen? because of this probability, let's say after some time, you see that this probability becomes 80%. Okay.
Yeah.
Now, out of 10 times, 8 times, you are going to Domino's. So you are exploiting Domino's, but you are not only exploiting, you are exploring Pizza Hut as well. You are not. So when you say what is a complete exploitation?
Like when you go to Domino's only.
When you go to Domino's only, that is a complete exploitation. What is a complete exploration?
When you equally go Domino's.
When you equally go to both. Now what you are doing, 80% time you are going to Domino's, 20% time you are going to Pizza Hut. So you are exploring as well and you are exploiting as well.
Yeah.
Are you getting my point?
Yes, yes.
This is the fundamental of reinforcement learning. Does not matter whatever level of study you do. This is how everything works. You will see complex versions of this, but the base concept will remain same. That this formula, that learning rate. So deciding what learning rate should be there is something totally depends upon your scenario, I would say, right? And it comes with experience. You train models for that. You do all those things, but that is a separate part. Right now, just understanding that how things learn over the time. Okay. Tell me if you have any question now. After this, I'll move to the last the example of the advertisement which I was speaking about. Right. We'll try to do that, and then we'll close the session. So, any question on this? That how reinforcement learning is working? Just make sure through this session you at least understand this much. Even if you understand this much, that is more than enough for me.
So I have a doubt.
Yeah.
Why we are choosing reinforcement learning for this problem? I think we might apply decision trees.
No, the session is of reinforcement learning.
Yeah, correct. I think this problem might suitable to decision trees also.
That is a separate. See, one problem you can solve through hundreds of methods, right? I'm telling you, how will you solve it using reinforcement? When does decision tree work? Tell me. When you have a past data, suppose you don't have any data about the restaurants, you don't know anything about them. How will you decide? Decision tree is a supervised learning, right?
Yes, decision tree is supervised learning.
This is not a supervised learning. Here you don't you don't know anything about Domino's and Pizza, how they work.
Okay.
Then how will you decide which place to go to? Tell me. If you have zero data, how will you decide?
Okay.
Is it clear?
Yeah, clear.
Anyone, any other doubt? Please tell me.
Can RL be used to label the unlabeled data?
You can do that. Yes, there are scenarios where you can do that. Yep. Like every time you go to certain thing, you can give a label, right? So for example, let's say this person, Sam, let's say he has totally gone 100 times. So he has a data set of 100 rows. And every time he goes, he can label it good or bad, right? That can be used as a training data.
Okay, thank you.
Yeah. Anyone, any other question on this? Yeah, it is based on most on probability. Yes, there are some more complex equations which come into the play, but this is the most sophisticated version which I'm telling you. But even their objective is also this only, that how do you change the probability based on experience. This is the maths that works in the background. This is not the only formula. Just to tell you, there are complex formulas as well, but which you can directly use. But this is a simple implementation of how it works.
So, what is the difference between RL and neural net? Does RL under the underlying principle uses neural nets?
No, it is not necessary that it uses neural networks. It can use, okay, there can be RL without neural network. There can be RL with neural network as well. Neural network is something, again, you learn, again, this is, you have data points. Remember, neural network is you have the data points, right? Based on those data points, you learn some patterns, correct? Here
Yes.
you're creating your own data sets.
Okay. So, what would RL without neural nets look like?
This is what it will look like, right? What I'm showing you right now.
Because the formula is oddly similar to neural net before
Yeah,
activation. If I'm not wrong.
this learning rate you would have seen in neural network, right?
Yes, yes. That's why I was asking is
So
if they were
again, I'm telling you, there are multiple ways to get this learning rate. One is through very simple A/B testing or very simple random testing or sampling methods are there. Statistical methods are there through which you can get, right? Another is to get through neural networks. The difference is that with neural network, you will get more accuracy, better learning rates, right? And you'll be able to test more data or basically get accurate numbers there. Through statistics, you can, based on some hypothesis, you will generate a learning rate. That can be good, that might not be good. So the difference is of the, I would say, accuracy of both methods. Okay, neural networks are more reliable. The only problem is training a neural network is a little bit on the harder side.
also, can you give example of RL being used in real life?
Real life, everywhere. A chat GPT, I just gave you one example, right?
Okay, sentiment analysis.
ChatGPT is one. Now let's talk about. I mean, it's not real life, but self-driving cars, right? I mean, they are reality now, right?
Yes.
Self-driving cars. So I live in Phoenix, right? Here we have self-driving cars, right? So they automate. I have taken them as well, and they are so accurate, right? They will go stop on the lights automatically, even, and it's not only about lights. The thing like this, you will think that okay, a car should stop on light or a car should stop at certain points, but let's say a car is going at a very good speed and some two cars, one car comes before it, one car comes behind it, one car ahead of it. It will automatically slow down or change the lane, something like that it will do, right?
So basically, robotics and self-driving cars or
It's
things
more
like
than
that.
those you will see in robotics.
Okay.
You can have in regular, let's talk about simple GenAI use cases, right? In GenAI use cases also, you can have, for example, different scenarios where, for example, again, I don't know how much you guys know about GenAI, but let's say when you are creating an agentic application where you're doing tool calling, right? In their tool calling, you rely on the prompt that, okay, this particular thing should be called with prompt. You can also add this reinforcement learning factor, right? Which comes under a topic called as context engineering. You provide this reinforcement learning there. So with the prompts so that they can train better, they can give better results.
Oh,
So
okay.
let me tell you a very simple example of this, that for example, uh, so suppose you are generating an article through ChatGPT. Okay, so let's say there's a user. Okay, there's a user who uses ChatGPT and he has to generate some article. Okay, so let's say this is ChatGPT. Okay, I'm using ChatGPT example because everyone can relate with it. But there can be a lot of examples. If you search around, unlimited example are there. Now let us say use ChatGPT to generate, and for example, you're generating, for example, let's call a story. Okay, generate a tweet, for example. Let's say you're talking about a tweet. So you ask ChatGPT to generate a tweet. Okay. Now what will happen? ChatGPT will generate a tweet for you. Okay. So let's say it gives a tweet anything, X, Y, Z, and anything. Let's say it has generated a tweet 1, for example. Now you get an option to basically say whether it is good or bad, right? So you can give a thumbs up or thumbs down, and you can also provide a feedback that, okay, this is something that I didn't like in in this particular tweet, for example. So you can give a feedback to this particular tweet. Okay.
Yes.
So what will you do? This time, user will say that this was the original tweet that you gave to me. Okay. Plus, plus you will give some feedback here. Okay. Now, if feedback could be a text, it could be a simple thumbs up, thumbs down, right? And you again pass it to ChatGPT that, okay, generate a tweet given that you generated this original tweet, this was your feedback. So what will ChatGPT do? It will generate a tweet 2 for you, correct?
Yes.
Or maybe what you can do, you can also ask ChatGPT to give a rating out of it. For example, let's say tweet 1 was there and its score was, you ask ChatGPT to rate itself. For example, okay, generate a tweet and it gives itself a rating of 6 out of 10. Okay. And next time it generates a tweet 2. Okay. And it gives itself a rating of, for example, 8 out of 10. Okay, your threshold, for example, is 9 out of 10. So what will you do? You will keep on repeating this whole process, giving thumbs up or feedback, something, right? And it will keep on improving the tweet, right, till it reaches a threshold of 9.5, for example. So this is also reinforcement learning, where ChatGPT is learning from what you respond to its content, and it is tweaking its content so that you basically like it.
Yes.
Do you get my point?
Yes. Yes.
So this is also a reinforcement learning, right? If you go a little bit advanced, you do RAG pipelines, you create agentic applications where you do tool calling. Let's say an agent has multiple tools, which tool to call, right? Over the time, you can make agent to learn that, okay, this type of tool calling is better. Again, for those who know it, similarly for RAG pipelines, right? When you do retrieval, you can add a reinforcement learning factor there. So these things are there which can be incorporated in real time. GenAI applications, robotics, right? And other things as well. I mean, we can discuss a lot, or I can bring those examples, but yeah. Or maybe you can do a Google after the session that, okay, a simple SQL Excel based projects can also have reinforcement learning. A complex projects can also have, but majority lies towards, as I mentioned, robotics, software engineering, those kind in those developments. Okay. All good, everyone?
Also, just to clarify my thinking, is are the rules of reinforcement learning hard coded?
There is no rule right now. Did I mention any rule?
The given set of specifications it needs to follow. For your example previously mentioned, if let's say I want the tone of tweet not to be harsh or rude, so this is now my guidelines
Your
or
feedback,
rules.
right? This is your feedback, how you want it to be.
Yes, yes. But I was talking just as you said, ki agents, it does all of this itself. So,
Agent does not do itself. You have to build that, right? Automatically, agents do not do reinforcement learning.
oh, no, no. I was asking if I needed to hard code these conditions like rating of 9 or rating
You
8.
can do that.
Okay, okay.
You can do that. There are ways to do that. Again, that will come when we study those examples, but it can be done in agents and all that. Okay. So this is it. Do you guys want me to cover the last example, or you guys are good? I mean, example is same. Just I would have shown through tables, numbers. Take some example of ads and see how it's working. It's the same thing, only what I just showed you, but through one more example. So do you want me to cover, or you guys are good for today's session? Maybe we can cover in some other session how you want it. I don't want to hold you guys for long. That's why. So let me know.
Today will be fine. I think if all are okay.
Sorry.
think there's lot to take home. I need to do a lot of study with I guess something new to me today, especially this Thompson sampling. So we will continue.
Let's
That's
do one thing. You guys go study, explore, right?
Yes.
And have the session once again, the example session, but again in some other class. Okay.
Yeah. Can you post me a LinkedIn ID so we can connect with you or chat with you later
Yeah,
on?
you can text me on WhatsApp, right? I posted the link there. You can
Great.
okay. You can connect with me on LinkedIn, and that's it, right, guys? Other example we'll cover some other time. I don't want to like make it this session hectic for you. So I hope you guys the intuition of how this works, right?
It was a great session.
Right.
Yeah.
Yeah, thank you. Try to read about it, right? And let me know if you like the session. We can have more sessions in future, right? Small sessions where we can pick up a topic, we can pick up some project, we can pick up any complex things, right? And we can work through it. So thanks again, guys, for joining the session.
Sanjay sent
Thank you, sir.
a LinkedIn invite. Please.
Yeah, I'll accept it. I'll accept it.
Yeah. Yeah. Thanks so much.
Thank you.
Thank you, guys.